Hey guys, Christian here. We've got a question today that's very, very similar to yesterday's question, which involved given the graph of an exponential trying to find the equation. Today we're doing the exact same thing, except we've got a logarithmic equation. So we're going to use the exact same principles about trying to follow the asymptote and use a point to gather up the dilation factor, but very little is actually going to change. Despite the fact that it looks different, we can deal with it in a very similar manner. Now, in logarithmic equations, the horizontal translation is given by the number that's added or subtracted to the x term. So in that case, that would be b. So when we've got a graph that's moved 2 units to the left, that would indicate that this b value is actually a positive number. So we would hope that the graph would look like this, x plus 2. Right, that's going to be our general equation for our log given the asymptote. Now the problem here is the equation actually says x minus b, so it's a little bit of a trick. Because we want it to say x plus 2, we have to actually say that b is equal to negative 2. If you say b is equal to 2, because it's moved 2 units to the left, it's gonna be wrong. Right? It's not gonna get the answer because they've given you a very, very specific equation and you have to follow the framework that equation is laid out. However, once you pass to that point and you found your value of b, all it takes, just like yesterday, we're going to sub in the coordinates of a point we know the curve goes through. In this case, again, we're going to use the origin because we know for a fact that the curve goes through the point 0, 0. We're going to sub the x in, sub the y in, sub the b in that we've figured out, and then rearrange it until we get a by itself. So we'll take our equation, we'll sub in y equals 0, log e. We're not really sure what a is at the moment, but we do know that x is equal to 0 and b is equal to negative 2. And all we have to do now is rearrange this until we can get a by itself. So before I do any rearranging, I'm just going to neaten it up a little. So we'll have log e a of a times 2. So we'll just put it as 2a. Now, in order to rearrange this, we need to get rid of the log. And to do that, we use the exponential. So we're going to say e of 0 is equal to 2a. And we know from our index laws that anything to the power of 0, e included, gives a value of 1. Once you finish that off, you'll see that a is equal to half. And then to write out the equation nice and neatly, if the question asks you to do that, this question actually didn't, but just for a little bit of bonus points, I guess. I've specifically written as x minus negative 2 so that it matches the form that the original equation gets us. That's all there is to this, guys. So any question where you're given the graph of an exponential or a logarithm, first and foremost, use the asymptote to figure out where it's moved and use that translation to get at least some of the information in your equation. Once you get past that point, you'll most likely have to use the coordinates of a point or possibly points, depending on how many unknowns you have left, in order to find the rest of the stuff. If you do have multiple unknowns, you will find yourself using simultaneous equations sooner or later. Guys, that's it for today's video. I look forward to seeing you on the next one. Thank you for watching.